You're listening to a V-Exchange podcast.
Welcome to the V-Exchange podcast. I'm your host, Ellis Booker. Today's topic is beating latency, data centers for modern applications. We're going to consider why latency can be a scourge of cloud-based businesses and how a modern distributed data center infrastructure can address that. Joining us is John Pancia, Senior Vice President Sales at V-Exchange. Hello, John.
Hi, Alice. How are you today?
Also joining us is Kyle Ackerman, Marketing Manager at Aproyo. Hello, Kyle.
Hi. Thanks for having me.
And finally, we have Deepak Ahir, SAP Startup Focus, Global Go-to-Market and Market Enablement at SAP. Hello, Deepak.
Hello, Alice, and hello, everybody.
John, let's start with you. Why is latency an important topic when we're talking about things like big data?
So, thank you, Alice. So latency, or some people look at it as speed, is really important when you're talking about gigabytes, petabytes, actually, of data that have to be sorted through, especially when it's unstructured data. And there are a lot of components to the latency that factor into the technology chain, if you will. Looking at geographic proximity is one. So being able to regionalize where connections are, where end users are compared to the source of the data, certainly makes big factors. If you look across the United States from coast to coast, for example, it's about 80 to 90 milliseconds to traverse cross-country on a data network. That is just an enormous amount of time when you're talking about petabytes of data that you have to analyze. So the more you could regionalize that into, perhaps an East Coast and a West Coast scenario, or even get down sometimes in a location in a data center. Geographic proximity becomes really important, whereas if you're in, let's say, a region, you could be down around 3, 4, 10 milliseconds. If you actually take that and go inside a data center, you can actually go down into the microseconds, which is really significant. There's 1,000 microseconds inside of a millisecond. You're actually able to condense that down to a couple hundred microseconds inside a data center. And the faster you're able to process the data, the more efficient you're going to be able to get meaningful information back to an end user.
And so there's a question for the group. The kind of applications that require that kind of sub-millisecond, microsecond sort of speed, we think of financial services, trading, for example. But there are other things coming online that require that as well. Anyone have a thought about what some of the modern applications that are going to need that kind of speed and absence of latency?
I can take that. So what we have seen traditionally is that, and SAP being essentially one of the business critical applications in most of the enterprises, what we are seeing is that earlier the ERP-based applications, or applications which ran businesses for our customers, were essentially focused on batch processing. You put something today, 2 days later, 3 days later, those systems would essentially get updated. So those were like systems of record. But that is changing today, and they are now being transformed into systems of innovation, which means it's more real time, it's more now, it's about taking decisions at this particular moment, which will impact millions and trillions of dollars of business for our customers and their customers. That is what essentially is where companies like ours, SAP, is trying to bring that particular evolution in our customer segment. And we're doing that with our flagship product called SAP HANA, which is an in-memory computing platform today, which basically provides about 10x to about 1,000x difference in terms of speed that it's bringing to different applications. And these today, the applications are not these applications which essentially you start in the morning, you go in the afternoon, in the evening, the applications are still running. These applications are about essentially taking data that's coming from a geospatial source, a data that is coming from a financial transaction, a data that is coming from a predictive algorithm, which is predicting a yield of a specific agricultural product or a manufacturing outflow, or the speed would be essentially saying that, before I actually get this consumer to use or swipe the credit card, how soon do I need to know that this consumer is not a risk to my business? So if you're talking about that, it comes into nanosecond, millisecond, and nanoseconds real-time information. And today, all these applications are written by large ISVs and small ISVs. But in last couple of years, as you would have seen, there have been hotbeds of startups who are basically, we call them as the new ecosystem that is being built, who are agile, flexible, and are extremely innovative in their ways. They are the ones who are pushing the limits. They are the ones who are basically creating new business models and economies for companies like us to basically leverage on those applications. And to leverage those applications, you need a super solid latent system. So that's essentially my comment on the question that you asked.
Sure, and you didn't mention it, but we've talked about this previously, you and I, Deepak, the Internet of Things, health informatics, knowing a patient is starting to have a heart attack. You don't want your application to realize that a week later, or even a day later, or even an hour later. You need to know in real time, right?
Absolutely.
So, yeah.
Absolutely.
You mentioned a second ago SAP's own in-memory database for big data, HANA. Can you, for those who might not be that familiar, can you tell us a little bit about SAP HANA and who's using it, how they're using it?
Sure. So as you know, that SAP has been traditionally an enterprise application software company. So essentially, we ran businesses of our customers for all these years, essentially 42, 43 years, going into 43 years now. And we have helped customers to transform their businesses right from manufacturing, automotive industry, and aerospace and defense, and then now strategic industries like retail and consumer product industries, life sciences, and things like that. There was a need for us to create a platform of choice which can essentially accommodate the changes that we bring to our customers, and more important is the demand that our customers are putting in. It was extremely important for us to really come up with this amazing in-memory database and an application platform, which essentially is faster, and not say faster, but essentially about 1,000 times faster than the regular databases that are available in the market in the current hardware scenario. It was also about simplification of design and operation, because a lot of times you can have a faster database, but if it doesn't really simplify your operation, you're going to end up having a challenge. The third important concept was about real-time business application. Not all businesses required this real-time, but today the companies are moving into real-time. It is the demand of the market for them to move into real-time. Hence, there was a need to basically have multiple application servers having huge amount of operational data storages, data mart, complex business intelligence tools, and all of these basically combined into one. And that's where essentially there was a need for a reinvention of a database. And that's what SAP basically took on, as saying that, should we look at a platform or should we look at creating a new database? And the answer for it was, we've created an in-memory computing platform which has the database capabilities that are available. But what it really offers today is beyond database storage, or beyond this so-called database parameters that you would look at. So just to kind of put it in context, a significant amount of businesses today, about I think 70,000 plus transactions today on financial streets, are essentially on this kind of a platform, in-memory computing platform like HANA. And a lot of them, about 70% of the world's, I would say, chocolate is processed on these kind of. Now, is chocolate a real-time need? No. But then when you look at financial transactions, when you talk about connected networks on Ariba's business environment, those are the ones which are very, very business critical in nature. For example, moving a supply chain of an automotive or an air force manufacturing or aircraft manufacturing part needs, if there is a tsunami that hits a particular, let's say, a location in a manufacturing hub, let's say, for example, in India, how soon can you predict it? And if you do predict it, how soon can you move an entire manufacturing unit to a different location, which will not hold up your other manufacturing priorities or KPIs that you have? So that's essentially what HANA was essentially brought into existence. That's where HANA is essentially today playing. And a lot of customers, I would say, we have about 250 odd strategic customers who are in the Fortune 1000 companies who are essentially using this, and it is running multiple applications on those.
So, John, looping back to you about as a provider of data center services, what are you seeing from 10,000 feet when it comes to customers moving to this real-time, in-memory type database, HANA or some of the alternative systems?
Sure. Yeah. There's many use cases and instances that we're seeing, across many different industries. Before I talk about that, I wanted to add one on the speed. So you talked about latency. We talked about the speed in which HANA is processing in memory and all of the processes that are being collapsed from a time frame standpoint. That's the throughput component. So it's the combination of the latency that's geographic and network based. It goes all the way down to your hardware and your in-memory, and then into the database portions as well. So those are the things that are really allowing, from a use case standpoint. I was talking to a pharmaceutical this morning, actually, we had in our offices, and they were talking about doing extensive DNA studies and in doctors' offices to be able to do predictive analytics on, whether you'll have cancer and what type of cancer and what year you'd have it. And, the norm has been over the years that, it'll take you a week or, it started out much longer, a couple of months to analyze that data, then down to weeks, then, over the past few years, it's been like a 2-day kind of window. This pharma company was saying they'll have it back in near real time. So within minutes they're going to have the data back, analyzing your complete DNA makeup and being able to tell you, with a certain degree of positivity whether you're going to have cancer and the types that you have or you're predisposed to and your risks associated with it. So that was just a very, very powerful use case that I'm sure resonates across a lot of folks. So it's things like that, things that change, people's lives, all the way to more fun things. And you and I have spoke about in the past a use case with the NHL and SAP, and being able to have sports fans all over the world do real-time analysis on hockey players and hockey games and scoring and statistics. So you see the sports fan being affected by this as well in a really positive way, where they're getting personalized data that would come back to them right to a mobile device, no matter where they're sitting in the world. So it's fun things like that, or to more serious things like the pharma example. It's really changing industry after industry.
And John, before we leave you for this question, I did want to ask, as a provider of data center services, how are you guys managing a sort of distributed environment where you might have a data center in one part of the country, possibly one part of the world, and an application, again, one part of the country, one part of the world, that require this low latency stuff? That seems like a new, very difficult architectural problem to solve. So how does vExchange, for example, address address that?
Yeah, it's certainly a newer trend in big data analytics and SAP are certainly a part of driving that trend. And when you talk about data being distributed like that to users that could be anywhere in the world or in any big city or small city, the content is there, right? And we're talking about real time. We're talking about milliseconds, microseconds, in some cases nanoseconds. You have to have infrastructure in the right places to achieve those kinds of goals, to provide that kind of user experience. Somebody who has an iPhone in their hand and they're interacting with an Uber application, for example, or they're doing just a simple web browser session, and they're sitting in a small city in let's say Pittsburgh, or in Philadelphia. In years past, you would serve that market from a Cleveland or a New York or a DC, and you would do kind of a hub and spoke architecture. And for many years, infrastructure was set up that way. Whether you're talking about telecom networks and dark fiber routes, or you're talking about content distribution networks, all of that infrastructure has been disseminated to what we call the edge, where you're actually taking that infrastructure and you're putting it locally. So now your latency, your throughput, and will go significantly down, and your user will have a much more positive experience with their application or the data that they're trying to achieve. And that's something that vExchange has been very good at. We have 15 data centers across the U.S. now, and we're strategically building based on that trend of being able to provide infrastructure in some of the smaller markets, if you will, that the demand for that infrastructure is there because of the content that needs to be there, because of the big data analytics that need to be delivered, because of the real-time nature of the data that must be there. If you're sitting in a doctor's office in Nashville, you want to have the same response as if you're sitting in New York City, and that all happens through technology infrastructure and being able to have that in the right place.
I want to bring Kyle. Oh, Deepak, just a second. I want to bring Kyle in for a second. Kyle, so from a Proyo's perspective, have you seen any of these cool, innovative applications that, again, require low latency and these new database architectures, these new data center and networking architectures? Any cool apps that you're aware of?
Sure, and I think the big thing that we've been kind of talking about is it's really across all industries. People expect stuff quickly now. Whether you're in New York City, whether you're in Milwaukee, Wisconsin, whether you're in Los Angeles, or even out of the country, people just really expect their apps and the information almost instantaneously. And having that kind of infrastructure set up is really, really important. And again, just to kind of another point to make is that it's all industries. We have another use case scenario where we have a client that's in the transportation industry, and they need to know where their drivers are, what the best routes are, and that's something that's pretty fascinating, in my opinion, to take a look, get information from your map programs, your Google Maps. Cross-check that with the routes that are being taken to make sure it's the most efficient use of time, of gas, for cost-saving perspective.
Good. Deepak, you had something to add, I think?
Yeah, I mean, talking about, the amount of scale and the latency that we're talking about, the speed, the aspect of speed that we talked about. I mean, the examples of customers that we see today are huge. I mean, and very specifically actually calling out to what John and Kyle actually mentioned about is, customers of SAP were essentially running a query, just a query execution in their ERP. It was taking on an average about 112.86 seconds. Guess what? Even that was a hindrance to a lot of their business units. They used HANA and they brought it down to 7.07 seconds. So there was a 93.7% execution, faster query execution model which was created. Why is it important? Because these guys are the guys who are basically building aerospace and defense products. For them, 112 seconds for multi-million parts that goes in a jet engine, 7 seconds is definitely an efficient, effective way of them for looking at it. Also, from a HANA perspective, compression, data compression has been a huge amount of, data is growing every day by day. But when you have so much of data, and when you're querying systems to identify the relevant results from a use case perspective, large amounts of huge terabytes of data has to be consumed in a way that it can be analyzed for whatever analysis you're doing. Hence, the database like HANA essentially has a database compression capability. The load times I'm talking about. How much time does it take to load the data into your infrastructure or your application environment? And then most important is the cache execution. How much of a cache can your data essentially rebuild on? And people have seen performances from 135 seconds to 2 seconds or 2.5 seconds kind of a caching execution aspect of it. This is the need of the hour as we go into conquering new businesses and new trends.
And that'll have to be the last answer because we're out of time. Thanks all for participating in this edition of the vExchange podcast. If you'd like to hear other podcasts, suggest show topics, or be a guest yourself, please visit vxchnge.com and get in touch with us. Thanks for listening.
You've been listening to a vExchange podcast.